What's the first model that you have learned just after starting to study nuclear physics? You started studying nuclear physics in class 12, and the very first model was Bethe-Weizsäcker mass formula, right? So what was that? It was as if I am considering the nucleus to be a liquid drop. Okay, liquid drop, right? Now what about the constituents inside the nucleus? We don't know. Suppose there are X protons and Y neutrons. What about them? We are thinking that just like a school assembly, all the students are out there, just like in a parade, everybody is working together. So here, everybody is working together in a collective fashion, and the behavior is like that of a charged liquid drop. So this is a collective behavior. Okay, charged liquid drop, and we try to understand the physics of all that using the Bethe-Weizsäcker mass formula. So this is what you have done in class 12. Then in graduation, the very first model that you learned about was shell model. And there you learned that just like matter has both particle nature as well as wave nature. So matter, it has got particle behavior as well as wave behavior. Similarly, the nucleus also, it can have a collective behavior as well as a single particle type behavior. And the collective behavior, we try to understand this thing through collective models. And the single particle type behavior, we try to understand. One of the most basic model is shell model. Okay, so this is what you have learned in your graduation days. Okay, good. So this is more or less what you have learned till now. Overall summary. There are other models as well. Fermi gas model. Yes, yes.
Why there are so many models in nuclear?
Yes, very good question. Why are there so many models in nuclear physics?
To explain one type of particular property, there is one model.
Now, let me tell you. If I know something, I don't have to use a different type of mechanisms to understand that thing, right? Suppose this is a chalk. What is this chalk? I know this is made up of atoms and molecules and all that. So this is the interpretation, though the only interpretation. And there do not exist 3 or 5 types of interpretation. Okay, only one interpretation, because I know what is this chalk. But very, very unfortunately, the nucleus, the entire structure, we do not know. You will ask me why? There are neutrons, there are protons, all that. Now, when I am saying we do not know, try to understand what I am talking about. This is a classical object, macroscopic object, right? But the nucleus, basically, it's a quantum system. Quantum system. And worst of it all, it's a many-body quantum system, not a single-body quantum system. Next, how many constituents are there in this quantum system? Well, the constituents range from 2 to say 200. Now, had it been very less, now we do know that the solution of 3-body problem is really hard. We can easily solve 2-body problem. Now, using computations, we can still solve exactly few body problems. But this number, 2 to 200, this is a very difficult number. Now, what about statistics? In statistics, the number is very large, Avogadro order, 10 to the power 23. There we use statistical techniques to find the average behavior, right? Now here, look at the number. This number, unfortunately, is too large for few body calculations, again too small for statistical calculations. So this is one of the very important difficulties why we do not understand the nuclear structure. And the next, even more severe issue is the knowledge of wave function. Now the wave function which will have knowledge of these many constituents, if I start writing down the wave function will have coordinates, position, momentum, right, of all the nuclei and all the other spin and other quantum numbers. You will find the wave function is extremely large and it will have so many numbers. It will not be of any practical use. You understand? The problem is twofold. And so, this is the reason why we do not know the actual structure. So what do? We resort to our good old days. What is that? We use a black body approach. We assume that this nucleus must behave like this, some sort of model. So these black body approaches are what we call nuclear models. So this is a collective model where we are assuming that all nucleons are working together. This is a single particle model where we are assuming all the nucleons are behaving individually. Again, we have got single particle plus collective models where we keep some part to work in a single particle way independently, and some part we assume they are working together. So there are a variety of models, and you understand the reason for that? Because we are unable to tackle this issue as of 2025. Again, everything as of now. So that's the overall scenario. Any more questions?